When we talk about climate, we mean the general weather conditions like temperature and rainfall that have occurred over a long period of time. Natural cycles in the Earth's climate happen on very long timescales of thousands of years. These long natural cycles are driven by the Earth's orbit around the Sun. Sometimes the Earth's orbit gets longer. This takes us further away from the Sun's heat, making the Earth cooler. The Earth also wobbles and tilts on its axis as it orbits the Sun. When the Earth tilts further away from the Sun, the northern hemisphere gets cooler. This causes more snow to fall, more glaciers to form, and the ice cap to expand. These changes in the northern hemisphere trigger a global ice age that affects the whole Earth. For the last 1 million years, the Earth has typically been in an ice age. Most ice ages have lasted around 100,000 years, with short, warm periods in between called interglacials. We are currently living in an interglacial today. Historical records of temperature or rainfall can tell us about the climate, but only for the last few hundred years. So how do we know about longer climate cycles of the deep past? Measurements are taken from ice cores, caves, coral or sediment cores and compared around the world. Studied together, these measures help us to build a picture of Earth's climate in the past. Ice cores preserve water and bubbles of air from the past in frozen layers. Scientists compare the physical and chemical characteristics of each layer to learn about the Earth's climate at different times. Carbon dioxide and oxygen isotopes trapped in the bubbles can tell us about temperature and rainfall in the past. So how has climate change affected Australia over the last 130,000 years? From around 370,000 years ago, the Earth was in an ice age. Then, 130,000 years ago, the Earth entered a warm period similar to today. Carbon dioxide levels were high and the climate was warm. Ice caps and glaciers had melted, causing sea levels to rise. Mainland Australia was separated from New Guinea and Tasmania by the rising oceans. High carbon dioxide levels helped woody trees and shrubs to grow into forests. A new ice age began around 80,000 years ago. Temperatures became cooler and carbon dioxide levels in the atmosphere fell. More of Earth's water was frozen into glaciers and ice caps, and this caused sea levels to fall, and as a result, Australia became connected by a land bridge to New Guinea and Tasmania. Cooler temperatures and less carbon dioxide in the atmosphere caused fewer trees to grow. Forests shrank and open grasslands expanded. Current evidence tells us that Aboriginal people first arrived in northern Australia towards the beginning of this ice age, around 65,000 years ago. At the height of the last ice age, 20,000 years ago, temperatures were at least 10 degrees colder than they are today. Glaciers formed in the mountains of New Guinea, southeastern Australia and Tasmania. Big rivers were often flowing, fed by monsoon rains in the tropics and the seasonal snowmelt, and large inland lakes were regularly full of water. Around 12,000 years ago, temperatures began increasing and carbon dioxide levels rose again. Melting ice caps and glaciers caused sea levels to rise, and mainland Australia was once again separated from New Guinea and Tasmania. High carbon dioxide levels encouraged more woody trees and shrubs to grow, and the forests expanded. Today, we are experiencing unnatural climate change caused by human activities. But how do we know that these changes are not part of Earth's natural 100,000-year cycle? Changes to our climate are happening faster than ever before. Average temperatures are increasing. Carbon dioxide levels from burning fossil fuels are now more than double what they have been for the past 2 million years. Changes in the Earth's orbit just don't match the speed of current climate changes. Studying the climate of the past can help scientists to predict changes that will happen in the future, helping us to better understand these trends and what impact they might have.